Preparing for integration engineering at HCA Healthcare interview? You've reached Candy Mentor, and this video is for you. We'll walk through 25 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is the difference between HL7 version 2, CDA, and FHIR, and when would you use each? HL7 v2 is event-driven messaging commonly used for admissions, orders, and results. CDA packages clinical information as structured documents, such as discharge summaries. FHIR exposes modular resources through RESTful APIs and supports modern application development. I would use v2 for established real-time interfaces, CDA for document exchange, and FHIR for new services or patient-facing integrations. In practice, healthcare organizations usually run all three, connected through translation and governance rather than replacing legacy systems overnight. While answering, distinguish message-oriented HL7 version 2, document-based CDA, and resource-oriented FHIR. Discuss transport, granularity, interoperability, legacy hospital workflows, modern APIs, versioning, and practical coexistence in enterprise healthcare environments. Question 2. Walk me through how you would process an HL7 ADT message from an EHR to a downstream system. I would receive the ADT message through a secured MLLP or equivalent channel, record metadata, and validate its structure in required fields. The interface engine would parse segments, apply routing rules, transform local codes, and deliver the result to downstream systems. I would return an appropriate acknowledgment, persist message history, and isolate failures for retry or review. Duplicate detection, correlation identifiers, alerting, and audit logs are essential because incorrect demographic updates can directly affect patient care. Make sure to cover message receipt, transport security, validation, parsing, filtering, transformation, routing, acknowledgements, retries, persistence, monitoring, and audit trails. Mention patient safety considerations and handling malformed or duplicate events. Question 3. How does MLLP work, and what problems must an integration engineer solve when using it? MLLP frames an HL7 message with start and end control characters so the receiver can identify message boundaries over a TCP connection. I would manage connection persistence, timeouts, framing errors, acknowledgements, and controlled retries. A successful TCP exchange does not prove the application processed the message, so I distinguish transport, commit, and application acknowledgements. I would also secure the channel, monitor queue depth and failures, and prevent retries from creating duplicate clinical transactions. In your answer, explain MLLP framing characters, persistent connections, acknowledgements, timeouts, retries, network security, message boundaries, duplicate delivery, and operational monitoring. Contrast transport success with business processing success. Question 4. What are the differences between an HL7 ACK, NACK, and application acknowledgment? An HL7 acknowledgment communicates whether a receiver accepted a message at a particular processing stage. An AA generally means accepted, while A indicates an application error and AR means the message was rejected. Some engines also separate immediate commit acknowledgement from later application acknowledgement. I would correlate responses using the original message control ID, classify retriable and permanent failures, and alert on unresolved errors. The key point is that transport acceptance is not always clinical processing completion. Be sure to mention acknowledgement types, acceptance versus processing status, error codes, message control IDs, retry behavior, and the danger of treating every ACK as successful business completion. Question 5. How would you design an interface engine workflow for routing ADT, ORM, ORU, and SU messages? I would first classify messages by message type, trigger event, sending facility, and receiving application. Shared validation and normalization would happen early, followed by destination-specific mappings and routing filters. ADT would support demographics and encounters, ORM orders, ORU results, and SU scheduling events. I would use reusable components, externalized configuration, separate quarantine queues, and clear acknowledgment handling. Version-controlled promotion and facility-specific testing would reduce the risk of changing one route unexpectedly. Focus on message classification, event codes, facility and application filters, reusable transformations, destination-specific rules, acknowledgment handling, quarantine queues, configuration management, and safe deployment across multiple facilities. Question 6. How do you handle HL7 version 2 segment, field, component, and repetition delimiters? HL7 version 2 defines delimiters in the MSH segment, field, component, repetition, escape, and subcomponent characters. For example, PID5 may contain repetitions and components for a patient name. I rely on an HL7 aware parser rather than splitting strings manually, because escaped delimiters and optional fields can break simplistic logic. I validate required positions, preserve meaningful repetitions, normalize values only when appropriate, and serialize using the message's declared delimiters. Explain MSH-defined delimiters, positional fields, components, subcomponents, repetitions, escaping, optional values, and why parsers are safer than manual string splitting. Include validation for malformed delimiters and escaped characters. Question 7. How would you transform a local hospital code into a standard code such as LOINC, SNOMED CT, or RxNorm? I would identify the source code system, target standard, context, and required level of equivalence before creating a mapping. A terminology service or governed mapping table should store source code, target code, display, version, status, and rationale. I would never silently guess an unmapped clinical concept. It should be quarantined or routed for review. Automated validation, change control, regression tests, and effective date management are necessary because terminology updates can alter downstream clinical meaning. Discuss terminology mapping ownership, source and target systems, code systems, versioning, concept equivalence, local extensions, unmapped values, validation, governance, and monitoring changes over time. Question 8. What is FHIR, and how do resources, profiles, extensions, and capabilities fit together? FHIR models healthcare data as resources such as patient, encounter, observation, and medication request. Profiles constrain those resources for a particular implementation, while extensions represent data not covered by the base model. Capability statements describe supported interactions, profiles, and search parameters. References connect related resources, and terminology bindings define permitted codes. I treat implementation guides as the contract. They determine required elements, cardinalities, profiles, operations, and validation expectations beyond generic FHIR documentation. In your answer, define resources, references, profiles, extensions, terminology bindings, capability statements, versioning, and conformance. Explain how implementation guides constrain general FHIR models for specific workflows. Question 9. How would you design a secure FHIR API for exchanging patient data? I would expose only necessary FHIR resources and enforce TLS for every connection. Authentication would use OAuth 2.0, commonly smart on FHIR, with short-lived tokens, narrow scopes, and validated issuer, audience, and expiry claims. Authorization must verify both user permissions and patient context. A valid token alone is insufficient. I would add consent checks, rate limits, audit events, input validation, pagination, and monitoring for unusual access patterns. Least privilege and data minimization reduce both exposure and operational risk. Cover OAuth 2.0, smart on FHIR, scopes, TLS, token validation, authorization, patient context restrictions, audit logging, rate limiting, consent, data minimization, and protection against broken object-level authorization. Question 10. How do you handle FHIR search, pagination, conditional updates, and optimistic concurrency? For FHIR search, I would use supported indexed parameters, enforce limits, and return pagination links rather than exposing unbounded results. Conditional updates can locate a resource by business identifiers, but the matching rules must be carefully constrained. E-tags and if-match support optimistic concurrency by preventing stale clients from overriding newer data. I would return precise HTTP status codes, preserve version history where required, and use ID impotency controls for operations that may be retried. Mention search parameters, continuation links, stable pagination, conditional requests, e-tags, if-match, version IDs, ID impotency, race conditions, and appropriate responses such as 412 or 409. Question 11. How would you map an HL7 ORU result message into FHIR observation resources? I would map each clinically meaningful OBX into an observation, using the local or standardized code as the observation code. Numeric values belong in value quantity with UCUM units, while coded or textual results use the appropriate value type. I would preserve status, effective time, reference ranges, interpretation, specimen, performer, and source identifiers. Panel relationships may require diagnostic report and has member references. I would validate units and codes, and quarantine ambiguous mappings rather than discard detail. Discuss OBX fields, result status, units, reference ranges, abnormal flags, performers, specimen context, effective times, identifiers, panels, and handling textual or coded results without losing clinical meaning. Question 12. What strategies do you use to prevent duplicate healthcare messages and duplicate FHIR transactions? I assume delivery can be at least once, so consumers must be idempotent. For HL7, I track sending facility, message control ID, message type, and relevant business identifiers. For FHIR rights, I use conditional operations or ID impotency keys where supported, backed by unique constraints and a replay-safe processing record. Deduplication windows must reflect workflow timing, because a repeated result may be legitimate. I also retain original messages so operators can distinguish duplicates from valid corrections. Be sure to cover message control IDs, business identifiers, ID impotency keys, deduplication windows, database constraints, replay behavior, exactly once limitations, and distinguishing legitimate repeated clinical events from duplicates. Question 13. How would you investigate an interface that suddenly stopped delivering lab results? I would first determine scope, one facility, message type, destination, or all traffic. Then I would inspect queue depth, recent acknowledgements, connection status, engine logs, certificates, and deployment changes. I would compare the last successful message with the first failure to identify data or mapping differences. After stabilizing the route, I would isolate bad messages, restore safe delivery, and replay only after confirming ID impotency. Finally, I would document root cause, impact, corrective action, and monitoring improvements. Outline a systematic triage, scope, monitoring, queues, transport, acknowledgements, deployment changes, source data, downstream availability, logs, replay safety, communication, and documented resolution. Question 14. What monitoring and alerting would you implement for production healthcare interfaces? I would monitor both technical and business signals. Technical metrics include connection availability, throughput, latency, queue depth, transformation failures, acknowledgement rates, and retry volume. Business checks might detect missing ADT events or an unexpected drop in lab results. Alerts should be threshold-based, severity-aware, and linked to runbooks rather than producing noise. I would track message correlation IDs, dashboards by facility and destination, certificate expiration, and end-to-end latency so support teams can act quickly. Include availability, throughput, latency, queue depth, error rates, acknowledgement failures, stale messages, certificate expiry, resource usage, business-level completeness, dashboards, severity thresholds, and actionable alerts. Question 15. How do you ensure FHIR is protected in interface logs, error queues, and troubleshooting tools? I apply minimum necessary principles to every diagnostic surface. Logs should use correlation IDs and masked identifiers instead of full names, dates of birth, or clinical content whenever possible. Payloads and queues require encryption, role-based access, retention limits, and audited retrieval. Alerts should not include FHIR, and lower environments should use synthetic or de-identified data. When troubleshooting requires content, I use approved tools and document access. Security reviews and periodic log scans help catch accidental leakage. Discuss HIPAA-aware logging, minimum necessary data, masking, encryption, access controls, retention, audit trails, secure support workflows, environment separation, and avoiding FHIR in alerts or developer consoles. Question 16. Describe a reliable retry and dead letter strategy for failed healthcare messages. I classify failures before retrying. Network outages and temporary downstream errors deserve bounded exponential backoff, while schema or terminology errors should move quickly to a dead letter queue. Each failed message needs its original payload, error reason, timestamps, attempt count, and correlation ID. Operators should correct the cause, validate the fix, and replay safely with ID impotency protection. I also preserve ordering where workflows require it and alert on aging queues, not just individual failures. Cover transient versus permanent failures, exponential backoff, bounded retries, dead letter queues, poison messages, alerting, operator workflows, replay controls, ordering, and avoiding duplicate clinical actions. Question 17. How would you migrate an interface from one engine or platform to another without disrupting clinical operations? I would inventory interfaces, dependencies, transformations, certificates, schedules, and operational owners before changing anything. Then I would establish baseline volumes and outcomes, build automated contract and regression tests, and run the new route in parallel or shadow mode where safe. Cutover would use a controlled window, explicit rollback criteria, and reconciliation of source, destination, and acknowledgment counts. I would involve clinical and application stakeholders, communicate downtime risks, and continue heightened monitoring after migration. Mention inventory, behavioral baselines, parallel running, contract testing, traffic cutover, rollback, message reconciliation, stakeholder coordination, change windows, and post-migration validation. Question 18. How do you approach interface versioning and backward compatibility for HL7 and FHIR integrations? I treat an interface contract as a versioned product. Additive changes are usually safer than changing meanings or removing fields, and consumers should tolerate unknown optional content where appropriate. For FHIR, I publish supported versions and profiles, while for HL7 I document segment and field behavior explicitly. I use contract tests, compatibility matrices, deprecation timelines, and consumer notifications. If a breaking change is unavoidable, parallel endpoints or routes provide a controlled migration path rather than an abrupt switch. Focus on contract ownership, semantic versioning, tolerant readers, additive changes, profile versions, content negotiation, deprecation plans, regression testing, consumer communication, and parallel support when necessary. Question 19. What is the role of interface governance in a large healthcare organization? Governance prevents every interface from becoming a one-off production dependency. I would establish ownership, naming standards, approved transports, security controls, terminology policies, data contracts, documentation, and lifecycle states. Architecture review should identify reusable patterns and patient safety risks before implementation. Governance must still allow justified local variation, especially across facilities and vendor systems. Clear change control, testing evidence, support responsibilities, and deprecation policies make the environment maintainable as integrations scale. Explain standards, ownership, architecture review, naming, security, terminology, documentation, change control, reuse, lifecycle management, and balancing enterprise consistency with facility-specific realities. Question 20. How would you handle a patient identity mismatch between two healthcare systems? I would avoid treating a local MRN as globally unique and would compare governed identity attributes through an MPI or identity service. Deterministic matches are appropriate for strong identifiers, while probabilistic matching requires confidence thresholds and human review for ambiguous cases. I would propagate enterprise identifiers, preserve source identifiers, and support merge and unmerge events. Every correction needs an audit trail and downstream reconciliation. Patient safety comes first, so uncertain matches should remain unresolved rather than being silently merged. Discuss enterprise identifiers, MRNs, MPI matching, deterministic and probabilistic matching, confidence thresholds, correction workflows, merge and unmerge events, auditability, and preventing unsafe automatic merges. Question 21. How would you design an integration that combines event-driven HL7 messaging with synchronous FHIR APIs? I would use HL7 events for timely notifications and FHIR APIs for resource-oriented reads or controlled writes. The source system remains authoritative, while an integration layer can normalize events and maintain a searchable projection. Clients must understand eventual consistency and use resource versions or timestamps when freshness matters. Correlation IDs connect an API request to downstream events, and retries remain idempotent. This hybrid design preserves reliable hospital workflows while enabling modern applications without forcing every interaction into one protocol. Cover asynchronous versus synchronous semantics, source of truth decisions, event publication, API reads, eventual consistency, correlation, retries, caching, transaction boundaries, and clear client expectations. Question 22. What testing strategy would you use for an HL7 or FHIR interface before production deployment? I would test at several layers. Unit tests cover parsing, mappings, validation, and terminology. Contract tests verify exact sender and receiver expectations. Negative tests include missing fields, invalid codes, malformed delimiters, duplicate messages, and unexpected repetitions. End-to-end tests validate transport, acknowledgements, persistence, and downstream display using synthetic data. I would also test load, security, retries, replay, and version compatibility. Every production issue should become a regression case, creating a steadily stronger safety net. Include unit, parser, transformation, contract, negative, security, performance, end-to-end, interoperability, regression, synthetic data, acknowledgement, and replay testing. Mention realistic edge cases and traceable test evidence. Question 23. How would you use an interface engine's channels, routes, filters, and transformers effectively? I separate intake, validation, routing, transformation, delivery, and error handling so each stage has a clear responsibility. Common logic belongs in reusable libraries or templates, while facility-specific behavior stays configurable and documented. Filters should be explicit and tested, and transformations should preserve source context and produce actionable errors. I externalize endpoints and credentials, use version control, and add structured metrics at each stage. This prevents a visually simple channel from becoming an opaque production dependency. Discuss separation of concerns, reusable components, early validation, clear routing predicates, transformation isolation, configuration externalization, observability, deployment packaging, and avoiding unmaintainable channel-specific custom logic. Question 24. Tell me about a time you resolved a difficult production integration incident. In a production incident, I first quantified affected messages and checked whether patient-facing workflows were at risk. I assigned a clear owner, communicated status and impact, and used logs, acknowledgements, and recent changes to narrow the cause. After applying a reversible mitigation, I validated recovery with counts and sample transactions before replaying failures. I then documented root cause, added monitoring and regression tests, and reviewed the process with stakeholders. Strong incident handling combines technical speed with transparent communication. Structure the response with situation, impact, diagnosis, communication, mitigation, root cause, prevention, and measurable outcome. Emphasize patient safety, calm prioritization, evidence-based troubleshooting, and learning. Question 25. How would you prioritize competing integration requests from hospitals, vendors, and clinical teams? I would prioritize using patient safety, regulatory deadlines, operational impact, affected volume, dependency risk, and implementation effort rather than stakeholder seniority alone. A production issue affecting medication or results delivery outranks a convenience enhancement. I would clarify requirements, identify the source of truth, estimate complexity, and make trade-offs visible through a scoring model or roadmap. For urgent work, I would define a safe minimum release, communicate milestones, and reserve capacity for incidents and compliance obligations. Mention patient safety, regulatory obligations, business and clinical impact, urgency, dependency analysis, effort, risk, stakeholder alignment, transparent scoring, delivery milestones, and capacity planning. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.